Good afternoon, everyone. I'm going to give a tutorial for the next 45 minutes. Roughly, I have 30 minutes of talk, so I want to give plenty of time for questions. If you have any questions as I go, please raise your hand and let's take them as well, okay? So let's start. The visual recognition market is growing extremely quickly. And the two main reasons for this are kind of obvious. One is the proliferation of images in the internet, and the second one is the expansion of use of mobile devices, especially for shopping and purchases and things like that. So if we take a look at visual recognition, let's start from the beginning. So on December 1975, Kodak and Samsung invented the digital camera. Now, ever since we can process images and videos digitally, computer vision has been developing visual recognition technologies to be able to understand our environment from a machine perspective. Actually, if you were this morning in the embedded vision talk, he was talking about these kind of technologies that are possible now that we can process images. Now, if you take a look at visual recognition, is a very large field of activity, and actually it can be divided in sub-branches. And I thought it was useful to give this because we get a lot of requests asking for things that we actually do not do. Some of them we do, and some of them have nothing to do with what we do, because even though everything is within recognition, the technology that is used for each one of these fields is quite different. So the most prominent branches would be image recognition, face recognition, object classification, and object character recognition. And each one of them has a different level of maturity, actually. So let's look at one by one. So image recognition, what it does is enables a fast search through an image database to match an image coming from typically a mobile device, like a smartphone or a tablet. So what we're trying to do is we first populate a database of images, say 10,000 images of book covers. We snap a book cover with a smartphone, and we try to recognize that picture, which is kind of a distorted version of that book cover because it was taken with a different angle, different illumination, and search to the database and pick the right one. People sometimes refer to this also as visual search. Face recognition is more or less the same principle. So we have a database of faces, and we take a picture of somebody, and we want to recognize that person. So we want to find the image in the database that matches that person. And face recognition is, well, you know, it is mostly used for security and something that has nothing to do with security, which is photo album organization. No? So you have your pictures, your 10,000 pictures, and you want to organize them. So when you type in the name of your kid, you find all the pictures of your kids. Object classification is a bit different in scope, and sometimes it is also referred as image recognition, but I wanted to create a clear distinction between these two. So instead of searching for a match in a database, object classification is trying to say what's on this image from the eyes of what would be equivalent to a kid. No? So I have a kid that is 2 years old, and I am teaching my daughter things. So she's asking, what's this, what's that? And I'm telling, this is a dog, this is a cat, this is this breed, and we can go on and on. So that's what object classification is about. But it's pretty useful, actually, because via object classification, you can give an image to an engine, and it can tell you what's inside. So it can tell you, I don't know, for instance, this is a steam train going under the Matterhorn mountain in Switzerland. Okay? So what's the use case for this? So if you think about it, it's pretty easy. Google. So when you type in a search term, in the early days, probably Google was looking for text in web pages that match your criteria and was showing you pictures that pretty much had some correlation. But now Google is looking inside pictures and trying to digest the information of those pictures and match your search by text with those images so that it makes sense both ways. The last one is object character recognition. So probably you have seen this, so recognizing the plate of your car or digitizing Asian books, for instance. So every time you are running a CAPTCHA, when you're typing in a form, that CAPTCHA is trying to learn those characters as well. So in this tutorial, I will focus on image recognition. So based on the definition that I gave, I will most of the time be talking about this kind of image recognition. And I will try to give you a bit of technology outlook and some overview of some guidelines on how to build applications that use it and best practices that I can share with you. So why am I talking about image recognition in an augmented reality conference? So I think they are a happy couple and they go well along together. And the reason is because image recognition is the door to most of the augmented reality experiences that we have now. So whenever we are trying to pop up some information, some digital, models, guidelines, etc., on top of an object or a game, the first thing that we have to know is what's that object. And if you're doing this at a large scale, hundreds of thousands of objects, you need image recognition first to pick up the right content and then start the augmentations, okay? So the outline of my talk will be consisting of these 4 points. I will talk about what works with image recognition, how to put image recognition into an application. I will compare some vendors with respect to the type of software that you can use with them, and I will share some outlook into trends that we see and that Catchoom is working on. In terms of what works with image recognition, I think that it is worth to think about ourselves as machines and try to see the world as if we were machines and see how they suffer a lot in terms of computer vision. So this is what the world looks like for a machine. So we have textured objects like a graffiti, textureless like a table that doesn't have any pattern on top, transparent objects like glasses, and we have deformable objects like ourselves or Yoda, and rigid objects like a Coca-Cola can or similar objects. Now, there are kind of two groups here, the top row and the second row. So on the top row, what we are seeing is that textured objects in the end have a lot of visual information. And by being unique, this visual information becomes very useful. So if we are building an image recognition system that has to go through all of the images that are in a database that is very, very, very large, what we need is that each one of these images is quite unique. So this is very well suited for textured objects, but not so much for non-textured objects. So probably this IKEA table, it comes in white, red, blue, maybe black, I don't know. But the thing is that from a camera perspective, besides color, we cannot know if it's this small or it's the other model that is this big. Okay, so we would need to use other cues. And from deformable and rigid, something happens as well. So if you think about a deformable object, so let's think about Yoda for a second. So Yoda has a lightsaber, and he can move all around this room very fast and be spinning around. Okay, so that's a lot of instances of Yoda that we would have to be able to recognize. So the thing is that we would need a lot of samples of Yoda to be able to actually recognize it with a single engine. Whereas a rigid object, probably with a single image, or at least that's how we do it at Catchoom, we have enough information to be able to then snap that picture of that can, whether you take it with a different angle or it has reflections, and we are fine. So in terms of what's possible with image recognition, we should focus on objects that are textured, that have some pattern that is unique, and that they are rigid. And so Catchoom is a little bit more flexible onto this. So if the object is deformable, like it would be, I don't know, a bag of chips, of potatoes, that's also okay. But as long as there is some texture, some pattern on it. And about transparent objects, I think this is a completely different beast. And I got this question recently, so I thought I wanted to share this story. So Logitech a few years ago launched a mouse that could run on glass surfaces. Okay, so it would track the position. Now, rumor has it that the day they had the demonstration, they had to scratch the surface to make the actual mouse work. Okay? So if you think about it, what was happening is that the mouse needed to see scratches and dots to have some notion of where it was. Okay? So even the most advanced technology made in purpose for something that like a transparent object still need some visual cues. And if you think about depth cameras, for instance, most depth cameras don't see glass because actually what happens is that they see through glass. Okay, so if you put a glass in between, they won't actually see that it is in front of there. So transparent objects is a completely different beast, and probably we would need some more elaborated algorithms to cope with that. Okay, so rigid objects and also textured is the best way to go with image recognition. So now let's move to how we put image recognition into your application. So I will cover some fundamental aspects. I won't go into a lot of detail, but I think that there are 3 pieces that are worth mentioning. The base of the pyramid probably is the image database. Second one, you will have to choose the software that runs with this, whether it runs in the cloud or it runs on the device. And the top of the pyramid is, for me, the content. So the image database is something that sometimes is overlooked, and we think that we find customers that look at the collection of images once they have been thinking about the rest. And we think, and we try to enforce the idea that the more you work on this database of images or learn yourselves what's possible and what's not, the better experience you will get for your users, for your final customers. In terms of technology, there are several options here, and I will tackle this from the vendor perspective so that you see who's doing what. And the last but not least is content. And I think somebody in the previous talk was saying that we have to think about the user, we have to think about something that is useful and meaningful and that they can take an outcome of this. So I'm not going to talk about content, but I want to give you this idea that whatever you build, whatever application you build that has image recognition inside, image recognition will be magic. But it will be even more powerful if your users come back and use it again and again and again, because whatever happens after the image recognition is useful for them. Okay. So let's talk about image databases. So bear with me for a second. So on the top row, you see a query image. That would be the one that you snap with your smartphone. Okay. And on the bottom, let's imagine you prepare your database with either one of these images. Okay, for each one of them that is in the database, you would obtain different results from the engine. So let's take a look at what happened. So the one on the left for the second row, now I will be talking about the second row. So the one on the left, it's green and it's the perfect reference image for us. So it's well cropped, it's a frontal example, and the results of our engine for that query image will be very high, probably 100% score. Okay. Now, if you introduce irrelevant background, like the second example, you're basically telling the engine, look for this image with this background, okay? So we are trying to do that as well. So still, it will work because this background doesn't have a lot of visual information, but you're just penalizing the engine without any need. So probably you want to look at the images that you uploaded and crop them. Third example, very bad practice. You take an image of your reference object and you add a lot of background that has nothing to do. And what happens with this background is that probably when the user snaps a picture of your object, the background has nothing to do. So you're again penalizing, and in this case, a lot, the engine. Poor viewing angle. So if you took a snapshot of the object with some angle, you're penalizing again, and if it's blurred as well. So if the angle is skewed or there's some viewing angle, or if the query is blurred, so any distortion on the query is fine, but please do not penalize the reference image in the database. You're just harming yourself and your users to get worse experiences. And I want to give you an example. So we have a customer that augments tattoos. You definitely want to take into account your database before putting something on your skin, okay? So be aware that curating the database is important. Okay, so I will, to simplify things in terms of image recognition software, I wanted to group them in cloud services and on-device SDKs. So cloud services means that your application takes a picture. This picture or some information is sent to a cloud service. The cloud service does the comparison with this long database and comes back with some information, response, product information, whatever. For on-device SDK, the idea would be that the database is local to the device. and that the recognition happens on the device. Okay, so the smartphone has enough power to do this. And there are advantages and disadvantages. So the typical use case for cloud service is whenever you have a database that is updated frequently, for instance, a magazine that is out daily or, I don't know, weekly or monthly, and you want to be able to update this content very frequently without having to do anything in the app. For on-device, there are several examples, but one is a TV show. For instance, if you are running a typical second screen application where there's a TV show and the user can interact, for instance, with a poll or responding to a quiz or something like this, you typically don't want that suddenly there is a spike of traffic against a cloud service. And let me explain you why. So if you look at cloud service vendors, probably, and you know their pricing structure, probably you've seen that they run on a cost per recognition, okay? So the cost per recognition means that every time you hit the server and it comes back with a response, you will pay for that, okay? Now, if you run an application for a TV show that is very famous, and it has 1 million users simultaneously hitting the server, this will be very expensive, okay? It's pure, easy mathematics. But if instead of doing that, you do it on the device, then what hit the server will be a request for content or a request for some level of activity, but you will not be hitting that server. And besides that, if you don't talk to that cloud service provider, probably what will happen is that the server will saturate and will not be able to support all this traffic in a single spike of, I don't know, 10 seconds, 1 million people, okay? Because cloud service providers are more designed to provide a uniform, flat traffic. So every now and then somebody requests, okay? So there are two softwares, and I wanted to look at some of the probably most important decisions in terms of features that you will take. So the first one is quite obvious. Cloud service requires internet access. Non-device SDK does not require internet access. In terms of speed, so the time it takes from the moment the user takes a picture till the time it is recognized, probably you may find same speed, okay, between the cloud and the SDK, contrary to what you would think. But in the case of cloud, it depends on the network. So what can happen is that some users get penalized with longer delays than others. And I don't know, sometimes you are on Wi-Fi, but the Wi-Fi is not so good, so the round trip is larger, versus on device where you know exactly what's the time delay. Content updates. So if you're running an application that you need to update from time to time from a remote server, like a content management system, whatever you do on this content management system for a cloud service, the changes will be immediate. So any user on your user base, regardless of whether they downloaded the first version or the third version they downloaded last week or this week, they will get the latest content, all the same. Versus on-device SDK, well, you require the SDK to create a local synchronization with the remote database, okay? And in terms of analytics, many people running applications for marketing purposes, they want to know how many interactions there were, when they happened, etc. So if you use a cloud service, the advantage is that because you're hitting a server, this server will just store the data and provide analytics that are, so for instance, in our platform, every hour you can get an update of the analytics results. If you do on-device, what you have to assume is that this device, at some point, has to send some data to the cloud, right? So whether it's, so you can have an application that doesn't require internet at the time of snapping that picture, but you may want it to be able to connect to the internet sometime at some point during the day, okay? Great. So let's move to comparing vendors. So I wanted to give what I think is more or less a fair overview of vendors. We are one such vendor. So I wanted to give it from the perspective of a product. So what's the offering, okay? And I will give you two subsets, those that work on the augmented reality space and those that work only on the image recognition space, okay? So this is, well, Metaio is there, I know, because I wanted you to be able to compare, right? So what was Metaio providing? It looks like we have more chairs, so It's the perfect time. Don't worry. Please go ahead.
They come from 4 chairs only at the front.
Gracias. Over there, yes. Guys, if you wanna come by.
It's also available for here.
Bueno, está bien. Thank you.
That's perfect.
Okay. So
4 more coming in about 4 minutes there.
yes, maybe I get one myself as well. But okay, let's go ahead. So the thing is, cloud service. Almost all providers have it by now. So you can upload your images. They have their own content management system. You have an application that connects to them. For on-device SDK, here I mean running hundreds of images or thousands of images. Okay. I know that, for instance, you can take Qualcomm Vuforia and take the SDK, and with around 100 images, you could still cope with it. But overall, what I wanted to say about augmented reality vendors is that even though they may offer image recognition, it is meant to be used for augmented reality. And let me explain what this means in practice. So with augmented reality, if you're familiar with any of these platforms, you probably know that the target images or the markers have to have a good spread of visual features all across the image, okay? And non-symmetric and well, plenty of things that you have to do. Image recognition is not that restrictive. So if you want to run an application that only uses image recognition, maybe you have to think about that, because those vendors probably are more restrictive in the type of patterns that you can upload for their use. Okay. Okay. So moving on to those who provide image recognition for image recognition. Okay. This is probably the list of top vendors. LTU Technologies and Moodstocks are French. Tina is Canadian, if I'm not mistaken. And in this case, I added another column, which is on-premises. So in the last slide, the cloud service is a software as a service, which means that you create an account, you have some pricing tiers or different options to pay for that service, but those images are hosted on someone else's server, typically the one from the vendor, okay? On-premises means that all those vendors offer the core technology for you to run it on your servers. So with this, you can build entire platforms, actually. Okay. So the case of Catchoom, for instance, Times of India, the largest publisher in India, has our engine running on their servers in India, and this allows them for very, very large traffic that they have. India it has a lot of people reading their magazines and the newspapers, and there's a lot of traffic hitting their own servers. So they manage entirely the stack from the bottom up. So with this table, I wanted to show you that Catchoom is offering actually on both spaces, the augmented reality space and the image recognition space independently, and that we provide from software as a service to on-premise to also on-device SDK. Okay, but why is Catchoom my favorite, besides being the CEO? So the real reason why I like Catchoom is that we have a set of ingredients, a unique combination of ingredients that makes our magic sauce. So the first one is that when we develop our technology, we take into account the real world, users, and images taken by users. And we take a lot of attention to using that instead of lab environment images, because ultimately it has to be run by a lot of people. And with this, we are able to cope with very difficult angles, blurry images, and even difficult light conditions and reflections. The second one is, one thing that we are passionate about at Catchoom is that the interaction is seamless. So what we want ultimately is that the user doesn't even realize that there is an image recognition going on there. We want to deliver experiences. We want to make their life useful via image recognition, but we definitely don't want them to get technical. We want them to to take pictures the way they are used to take pictures, not the way we need them to take pictures. Okay. The third one is, I think that here I should mention that the results speak for themselves. We have been benchmarked by an independent company comparing different vendors, and our results achieved 98% accuracy, and our closest competitor was 20% less accurate. Okay, and we provide this within half a second. Okay, one of the properties of our software as a service, if you use it, is that we have servers in the US and in Europe, and whatever application that you deploy that is global, your users will be routed to the server that is closer to them, without them doing anything in particular. So this ensures that they have a very good round trip and that the experience is really engaging for them. And the last is that, as I said before, because we provide on-premises license, you can build very scalable platforms for your own and use our software, which is meant to be scalable. We design it in such a modular way that you can decouple several elements of the core technology, and software architects can really build platforms that are quite large. And I cannot give you numbers of the customers that we have, but these are hundreds of thousands of images and millions in cases. Okay, so maybe you have not heard about Catchoom, but actually we are in fact one of, if not the most used image recognition engine out there. As of April this year, we had already delivered more than 420 million image recognition interactions across the platforms and applications that use our software. This is not mine. Okay, so let's move to some trends. This is the last part of my talk, and what I wanted to discuss is some things that, three things mainly that we are seeing in the market and that we are working on. So the first one is what we call extended search. So imagine you are an e-commerce, and typically in an e-commerce you have a certain number of products that are very popular. We call this the head, and a very long tail of products that get interest of users from time to time. Okay, so now imagine if you can run this subset of objects on the device, so you don't hit any server, you don't get that load on the server, you get the response fast and on the device, and then if you don't get a response on the device, then you search for it in the cloud for this long tail of objects. So this is something that we have patented and that we have technology to support this. The second one is industrial application. So let's place yourselves as a field technician inside the Star Destroyer. So bear in mind that you are in a war, okay, and you have to fix a piece of equipment. Now you have to do it fast, and you probably have a lot of engine parts in that Star Destroyer. So in order to be able to be in front of that piece of equipment, probably with the smart glasses or whatever in the Star Wars world, and see that piece of equipment, you need to first search a very long, very large data set of engine parts. So what we are working on is trying to do the same thing that we do for images that have a lot of texture, but for objects that are not necessarily very textured and that have instances that can be in dark conditions, that can have stains, etc. So we are that's one of the axes of our that we are doing at the Catchoom Labs. The second one is fashion or apparel recognition. So if you have some kind of appeal for fashion, probably you have thought of snapping the pictures of the guy sitting on the floor who has very nice shoes and trying to buy them online. Okay, so if you're trying to do that, the thing is that besides brands like Desigual or Cousteau, who have a lot of design patterns on their clothing, the rest is, well, just like what I'm dressing now. So this is a black shirt, not many visual cues here to use. So what we are doing here is investing in recent advances in the field of computer vision using a technique that is called deep learning. So what deep learning is trying to do is through convolutional neural networks try to understand and classify the objects by learning from different samples. Okay, so this is a simplistic approach. But what deep learning has given is a significant boost in the performance of object classification and being able to really go deeper. To give you a hint of this, Google at Google I/O just a week ago, in their keynote, were talking about deep learning because they are using this with farms of GPUs, trying to be better and better at learning with different layers the content from images. Okay, so a few takeaways from my talk. So the first one is I want to share with you that image recognition is the door to a broad range of applications and services and is in a very fast-growing market. The second one is bear in mind that if you work on the image database, you can significantly improve the results for your users. I know that sometimes you build self-serve platforms, so platforms that have user-generated content. So even if you have user-generated content, you can still try to educate and explain these best practices to your customers, and I think that they will appreciate that. The third one is bear in mind that you have options. You can run on device and you can run on the cloud, and there are different benefits to that. So bear in mind your use case and your business model for that. And the last one is, as I said, Catchoom is already behind 420 million interactions to date, and we are looking at trends and working on research on them. So thank you very much for your time. And if you want to, if you're staying here for the next couple of days, please visit our booth for live demos. Thank you. So, well, if you have questions, we have like 15 minutes more. So I'm here for you guys.
So you said there's an AR space and image recognition space, so Catchoom supports. What is the significant difference? The AR space is first the image, the target image has to be recognized. Then we augment the whatever you wanted to show on top of the image. So still that.
Okay, so if I understand the question is how do I differentiate between the AR space and the image recognition space? So in terms of image recognition, you probably can go beyond what you can do with augmented reality. So you can recognize objects that are not necessarily flat, for instance, sculptures or landmarks, and you don't necessarily have to have patterns that are well spread in terms of visual patterns. So there are more limitations in augmented reality than in image recognition. And vendors that are in image recognition typically have like what we do. We don't necessarily have to be so restrictive about the target pattern. There's did I respond to your question? There's a question over there.
You mentioned times of India.
Yes.
Needing to make image classification. In regular serving of news, you don't need to do image classification. What is the use case?
Sorry, I'm not sure I get the question. So you asked about times of India and object classification.
What is the use cases that they need hundreds of millions of...
Okay, so Times of India uses our image recognition engine for image recognition, not object classification. So they have an application and other applications, but the main application is called Alive, and they use it for publishing. So they are a publisher and they have a number of publications, and what they provide is for certain pages every day have interactive content like videos or polls or things like that. So every day they have more and more images going out live. Yes?
What's the package size of each request of the cloud recognition?
What's the what, sorry?
Package size of
The size of
the package.
when you say the package, you mean what we send to the server? Okay, so we are actually sending the images, and the images in JPEG format. And the reason why we do that is that all your smartphones get very good accelerators that compress JPEG in a matter of nanoseconds, or I don't know how much. So we take advantage of that, and we send images that are optimized in size. So typically we use grayscale image. Is it possible to close the door, or well? Anyway, so they are optimized in size and in resolution, I mean, and then they are in grayscale. So they take 10, 15Ks, more or less. Yes. Yes.
So for the on-device recognition, how big do the data sets get for that?
It depends on you. So for each image, it's around 12 kilobytes, 12, 13 kilobytes for each image.
So it's literally just each image you want to recognize. There's no big deal. Any other overhead?
No, the only overhead is that for a collection of 100 images, because the way our content management system works, for each image you can attach some metadata, like a text or a URL that you would like to trigger. So this you can put it, that's very, very small, but you can put it to whenever there's a scan inside the SDK, you can retrieve that information and, I don't know, pull that URL. Yes?
I guess just to follow up, so Catchoom just does pure image recognition and sort of pose estimation or anything like that.
So by pose estimation, you mean the augmented reality part?
I guess so, yeah.
Okay, so Crafter is our software as a service. So it's actually Toolbox, okay? So Crafter has the content management system, the cloud image recognition API, a content creator, so within a web interface you can customize the look and feel of your experience, and then the SDKs. And we have an augmented reality SDK that does the pose estimation, tracking, and overlaying content, and an image recognition SDK, which is a lightweight version of the AR. And then we have the on-device SDK, which is purely for on-device. Yes?
How much time it would take to process the image first time when I just send the image as a target?
Okay, so assuming you're running on 3G, for instance, so you're quite dependable on the network, but it would take 1 to 2 seconds to upload the image because the uplink is not as good as the downlink, okay? Once we get the image, it takes roughly 100 milliseconds, 200 milliseconds to process, and then we're back. So for the user, the experience is 1 to 2 seconds, actually. And over Wi-Fi or 4G, you get to half a second, more or less. So half a second from the moment it snaps the picture till the time the response is back. Then if you have to open a URL or show whatever, it depends on your application. I don't know which one to take. So let me take that gentleman over there.
Is it possible to use Catchoom SDK to recognize face, human face?
The answer is no. But having said that, if you want to do face recognition as such, we don't offer that. But if you have an image of somebody, let's say a poster of Obama, you can still recognize it because it's a very particular instance. Probably he's looking from one side, he has some shades, and this particular instance, we are capable of recognizing it through a very large data set of, I don't know, posters of people. But this doesn't mean that if I had a picture of Obama in any sample or daylight or whatever, I would be able to recognize it. Over there?
That work for 3D recognition. So for instance, if you're on the side of a vehicle and you have the section of the image where it's 3D, and then how do you integrate with other 3D tools? So if you want to go out and do object recognition, do you have an answer for that or on that?
Okay, so if I understand well, there are several questions here. The first one is if we can recognize a 3D object. So the answer is yes. So even though we use images to recognize them, with the way that we design the algorithm is able to cope with objects that are not necessarily flat. Okay. Having said that, you put the example of a car. So a car doesn't have much texture on it. Okay. So a silver Toyota Corolla is quite similar to a silver, whatever you name the brand. So we won't be that much capable of recognizing each instance separately. If it was a picture of that car in a, I don't know, an ad in a magazine, probably it would work well, very well. And then you said about like authoring 3D tools and in combination with ours. So if you have a 3D authoring tool and you have a 3D model of a real world object, is that what you mean?
Yeah, you want to overlay that based on image recognition.
So the image recognition will work on the reference image that you use as a trigger, the marker. Whatever you put on top as a 3D model, Crafter supports that. So the SDK is capable of rendering 3D objects like OVG and Collada on top of that. But the rendering part has nothing to do with image recognition. So once we have recognized it, we can put whatever we want on top. And then the tracking component is what starts to do the pose estimation that is able for you to look at different angles of that car, for instance. There was a question here, yes?
What's the performance for if the target is text, like a picture of English target?
If there is text in the image? So I didn't put it as an example, but we should avoid that. So text is just creating a lot of feature points all over the place, and they are so repeatable with any other text that we cannot do much about it. Actually, what we have is a special module that it eliminates text. It eliminates text and looks at, for instance, an image that you have that triggers that content. Actually, what our guidelines, what they say is, if you have a page that has a lot of text and an image and you want that to be interactive, upload only the image and put the call to action on that image, not the entire page. Yes?
What about cases where you have occlusion or a portion of the image is obstructed, you can see?
It works equally fine. That's also part of the design of the technology. It copes with that, so we can go with very, very few key points and still be able to recognize that object. So if there is an occlusion, which happens all the time, or a reflection, which for us is like an occlusion because you would see a very bright white spot that we don't have anymore the visual feature from that, it also works well.
The second question was that you showed that long tail with
Yep.
wine and the head and the tail. So for the SDK, do you need to have that entire image database as an app or basically as part of that local data and is stored?
Yes, so if you do want to have such a hybrid approach where you run on the device for the head and then the cloud for the rest, on the device you would have to have a local database that you could still synchronize every now and then, okay? So it's not that it is static and forever and ever. You could still synchronize it. But the point is that at the time the user opens the app, that database is fixed for that experience.
We're going to take the last question now.
Okay, last question.
How do you handle the case in which, for example, I'm sitting here and I take a picture of the speaker, and then somebody who's a couple of rows ahead of me takes a picture of the same speaker? How do you account for the difference, variation in image?
In angle, you mean? We cope with that. So, well, if you're familiar with computer vision algorithms, there is the concept of scales from the image. So we use this kind of knowledge to try to cope with objects that are very distant. And actually, the last version of the engine, 3.3, can cope with objects that are far like this table or this projector. And let's say this is a small poster, and I'm taking a picture of this full room. So even as small as 20% of the image, we can cope with it. So that's quite significantly small. And this works well. So for instance, we have an example of a real estate agent that wanted to have the posters that are on the houses to be interactive. And the example that he was taking is shooting pictures from the car. So you were driving on the street and taking pictures of a poster that is this big from over there. And it still worked. So we put emphasis on this kind of being able to cope with distant objects. Yes, I will be in my booth tomorrow and the day after. And my colleague Richard here on the second row will also be there. So if you have more questions, please come by our booth and see the demos. Okay, thank you very much.